Hello everyone, this is James Shore with another test-driven JavaScript video. I'm recording this on April 23rd, 2013, picking up a day after our last episode. In this episode and in this chapter, we're working on getting smoke tests of our front-end code working. And what we have set up so far is we have Phantom.js set up and running so that when we run our Jake script, we actually run Phantom.js, which is a headless web browser, which actually loads HTML in a browser and pushes some mouse or sends some events in and checks to see if the line has been drawn. Or rather, that's what it's supposed to do. It's doing everything except actually checking if the line has been drawn. And in the last episode, we had just finished factoring out this new SVG Canvas class so that we could ask the drawing area what its line segments were. Unfortunately, that didn't work. And the reason for that, let me load up the smoke test here. So in our smoke test, we get the drawing area and we do mouse down, mouse move, mouse up. Then we get the SVG canvas for that drawing area and we ask it for its line segments. And when we do that, if we look at our output, we can see that we're getting nothing back. And I am pretty confident that the reason we're getting nothing back is because this line segments function that we wrote, actually that we just extracted, this relies on asking the Raphael paper to loop over its elements. And even though we're operating against the same underlying DOM, Raphael has got some sort of internal state that it's keeping track of which elements have been drawn, and that internal state is not being preserved because we're actually constructing a new SVG canvas here, and thus a new Raphael object with new state. So Raphael doesn't actually reflect the underlying DOM. It has its own little cache. And as usual, caching is fraught with danger because it gets out of sync with what's going on in the real world. So what we need to do is we need some way of inspecting whether or not this line has actually been drawn in order for us to finish this chapter and get this test done. Again, all we're trying to do here is just prove that in a real browser, somebody can come along, draw a line, see it work. That's all we really want here. And we've got the drawing a line part, but we don't have the see it works part. There's a couple of ways we could handle this. One way would be to somehow get access to the real Raphael paper that our production code is using and ask that for its line segments, or rather the SVG canvas, which is basically the same thing. The other approach would be to modify this line segments function so that it looks at the real underlying DOM. And both have their advantages and disadvantages. Looking at the underlying DOM is a little bit more complicated, but it kind of solves the problem for us. I think I like my functions to be as stateless as possible. I like them to be immutable and stateless because it resolves a lot of problems. So if we had this look at the underlying DOM rather than asking Raphael what was going on, then we could construct SVG canvas on any element and it would just work. Maybe. I mean, we are using Raphael, so that's a bit tricky. If we were to try to figure out or get the actual SVG canvas that we're using, now we've got to muck around. We've got to somehow get access to that variable, which I guess is exposed when we initialize the drawing area. It's exposed from our client. We return it here. And that is being set up here, and it's not being assigned to anything. So I guess one way of solving this would be to say var drawing area is blah, or even WikiPaint drawing area is blah. And then in our Phantom.js code, we could say SVG canvas equals WikiPaint dot drawing area. That would work, I think. Actually, let's try it, see what happens. But even if it does work, I'm not sure if I like it. Oh, look at that. It totally works. Wow, that's really easy. I think I find all my objections melting away because that is really, really easy. Hmm. The other option here, the other option here is to go into here and have this look at the DOM directly, which would take us a lot longer and be a lot more complicated. Let's see. The cheap and easy way versus the right way is sort of the eternal question for software development, isn't it? Well, the question is how bad is this? And how much better would be having SVG Canvas look directly at the DOM be? I don't know. Let's punt. As usual, when I don't know something, I will just do something else for a little while. So let's just make a note to revisit the question of whether SVG Canvas should look at DOM versus asking Raphael for elements. And the implications of this are that this affects whether or not we put the drawing area in a global variable for access by Phantom.js. Yeah. I don't really like this. Let's at least... Yeah, I feel like we're exposing the internal state of our client, of our drawing area. And I don't like that. Encapsulation is there for a reason. Encapsulation protects you from changing one part of your code cascading out to a dozen other parts of your code. Yeah. But it's so easy. It just works. Well, except what? Oh, right. Let's fix that. Yeah, let's run with this. We'll get this working. We'll get everything else done. And then we will come back to the question of whether or not we want to go to the trouble of making this actually look at the DOM. It is possible to make it actually look at the DOM. It's pretty much doing that now, except for this part. We just have to get the nodes out. The question of how that's going to work in IE could be a bit of an issue, though. So, yeah, it's a bit tricky there. And then there's also the question of how do we get those child elements? It would require us to modify our HTML element. It's all a bit complicated. So given that we're only doing this in one place, I'm inclined to be okay with it for now. The general rule of thumb is you can make ugly code. It's fine to make ugly code as long as you only do it. As long as the specific ugliness you're talking about only shows up once or twice. Once it shows up more than three times or more, then you've got an ongoing problem. So yes, obviously this is ugly code, but one bit of ugliness is not a deal breaker. Can you hear me? Can you hear me rationalizing my way out of doing half an hour of work? Yeah, this is what it is to be a programmer. All right. Well, I think I'm going to stick with this. It's just working so well. Anyway, so what we need to do is we need to assert that these two things are equal, and we don't have our expect.js in here. So let's just say if, well, let's see. Let's pull this out. Pull that out and pull this in. And what's an easy way to compare two arrays? You know, I'm not sure. I'm going to look it up real quick. Okay, I'm back. I found a really cheap and easy way that's sort of obvious, actually. We'll just say, we'll use the stringify. So this is our actual line segments. And our expected line segments is 10, 20, oops, no string, is 10, 20, 50, 60. And we will expect these two to be the same. So we'll say if json.stringify actual line segments does not equal our expected line segments, then we'll do something. And in this case, we'll say did not match. And here we'll say did match. See what happens when we run that. Did not match. Let's go ahead and see what's going on here. Oh, yeah, that. I'll just go ahead and put quotes around it. It's a bit ugly, but that's always true of the code when I first write it. It's always ugly at first, and I always improve it when I come back to it. So we will do that here. You've seen that over and over throughout the screencast, so I'm not going to sweat it too much. Okay, so here we can return a value. We can say return that, and here we can say return that, and then this will give us that result, so we can actually do a console.log result like this. And hopefully that will work. Yes, it did. And now let's change this to be 60, 60, and we should see it say did not match. Oh, it says it did match. Oh, that's because mouse up doesn't actually matter. Let's change mouse move. Perfect. Okay, so now let's have it return null. We'll have it return an error string if it didn't work. So this will say draw lines drawn expected blah blah blah, but was that? Otherwise we'll return null. And let's just smooch this together a bit. This is obviously, I mean, basically what we're doing is we're starting to write a little mini test framework. We don't really want to do that, but since we're just doing this one test, I think it's okay in this case. And here we'll say, rather than printing result, well, we'll print the result, say if result, then console.log, test failed, or actually we'll just log the error, rename this to error, and we'll exit with a non-zero error code. Otherwise, we'll exit with a 0 error code. Awesome. Line drawn expected this, but was that. Phantom.js test failures. Perfect, perfect, perfect. And now if I fix this, it should work. Cool beans. All right. All right. I think we are really close to being done here. I think I'm going to punt on, we're not going to look at the DOM. We're just going to do it the way we're doing it. It's good enough. We've modified the smoke test to draw a line and assert that the line is present. We've got a bit of final polish. Let's just double check that this is all working. It looks like it is. What happens if I take out the something we need, like HTML canvas? Ooh, it says it's okay. Looks like we need a try catch in our Phantom.js code, saying undefined is not a constructor. Let's just catch everything. We'll log it and exit with an error code as well. In fact, we don't need to log the error because it's printed out for us right there. I guess we do have to catch it. And semicolon. We're running a little bit long, but I think this is the end of the chapter, so I really want to wrap this up. I'm going to take a moment, figure this out, be right back. Okay, I figured it out. The exception was actually occurring in the browser code. And here we'll just say exception in Phantom.js code. So there, I think we are set. I think it's all working. Fails when it's supposed to. And it passes when it's supposed to. Awesome. That means that our smoke test now includes client-side code. We fixed our HTML. So that is it for this chapter. Next time, maybe we'll get into modules. Maybe we'll get into something else. I'm not sure yet. I'm going to think about it, and then we'll pick up again with the next episode. Just to summarize what we've done here, we have created smoke tests for our WeWikiPaint application so that if we make changes, mistakes in the way the HTML code is written, the way our HTML and our JavaScript code is hooked up together, we'll see that error. What we're doing in this Phantom.js code is we're drawing with a mouse, checking that it had the right results. And the way that runs is here in our smoke test code, we're running Phantom.js right here. We're running Phantom.js as its own process. That's actually spawning a web browser without any window, doing our stuff, and then we're looking at the exit code to see if it failed. So this is a really important step for us. It gets us to the point, I think, of having really, really thorough and solid tests. And as always, just completely run from one command, from a command line, and it's pretty fast too. So I am pretty happy about this. Next time, we'll start a new chapter. Thanks very much for watching, everybody. I will see you next time.